Hello everyone, this is the Pathology Explorer short video series, and today we will explore the classification of hypersensitivity diseases with Part 1. Focus on the Type 1 reaction. The immune system turns from protector to problem when the immune response is exaggerated or inappropriate, harming the body. A hypersensitivity reaction is an altered and harmful immune response toward a specific antigen. It can occur after repeated or prolonged exposure to that antigen, and is characterized by two main phases. Sensitization phase. The body is first exposed to the antigen and develops a specific immune response against that particular antigen. Effector phase. Subsequent exposure triggers a pathological response, which can range from a local reaction to a severe, and sometimes fatal, systemic reaction. Let's walk through the sensitization phase of type 1 hypersensitivity. It begins when an antigen, A, enters the body. Antigen-presenting cells, particularly dendritic cells, capture the antigen and present it to naive CD4+ T lymphocytes. Under the influence of specific cytokines, especially interleukin-4, these naive T cells differentiate into T helper 2 cells. The activated Th2 cells express CD40 ligand and secrete critical cytokines like IL-4, which signals B cells to undergo class switching and start producing IgE antibodies, and IL-5, which helps recruit and activate eosinophils. In response, the B cells mature into plasma cells that secrete IgE antibodies specific to the original antigen. These IgE antibodies subsequently bind tightly to Fc epsilon Re receptors on mast cells and basophils, effectively sensitizing them. At this stage, the immune system is now primed. From now on, any future encounter with the same antigen will trigger a rapid allergic response. Now, let's see what happens upon re-exposure to the same allergen. Upon re-exposure, the allergen cross-links IgE antibodies already bound to Fc epsilon Re receptors on the surface of sensitized mast cells. This cross-linking acts as a trigger, causing the mast cells to undergo rapid degranulation. As a result, histamine and other inflammatory mediators are released. These mediators produce immediate allergic symptoms, including increased vascular permeability, leading to edema, smooth muscle contraction, resulting in bronchoconstriction, and mucus secretion. These are the hallmark features of an acute allergic reaction. But the response doesn't stop there. Both mast cells and Th2 lymphocytes continue to release cytokines, which recruit additional immune cells, especially eosinophils, initiating the late-phase response. Once activated, eosinophils, driven by interleukin-5, release toxic granules like eosinophilic cationic protein and major basic protein. These substances damage surrounding tissues, leading to chronic inflammation, tissue damage, and structural remodeling, features commonly seen in persistent allergic diseases like asthma.